In this video, I'm going to walk you through two more examples of taking derivatives of inverse trig functions. So this first one, the function is h of z equals arcsine of 5z plus arctan of 4 minus z, and then that whole quantity is being raised to the 27th power. Okay, so definitely not something you'd want to try to multiply out first. Instead, we're going to use the chain rule. So the very outer function is going to be that raising it to the 27th power. So if I think about x to the 27th power, the derivative would be 27x to the 26th power, and the same idea applies here. So I have 27 times this whole thing. I'm not changing it at all. I leave it as is. I just rewrite it back down. Wow, that's looks like turked. Okay. Plus arctan 4 minus z, all of that to the 26th power, and then I have to multiply by the derivative of what's inside. Okay, so the derivative of arcsine, what we saw is that that is 1 over square root of 1 minus, normally it's x squared, but in this case that inside function is 5z. So 1 minus 5z squared. Again, wow, that does not look like a 5. That looks like a really weird s. I'm going to rewrite that. 5z squared. But now I have to also take the derivative of 5z, which would be 5. So I'm going to change this numerator to be 5. So this part, this is the derivative of arcsine of 5z. And then we do plus, and I'm going to go on to the next line. We need the derivative of arctan of 4 minus z. So that will look like 1 over 1 plus x squared. In this case, the x, the input here is 4 minus z squared. And again, if you're wondering where those are coming from, it's coming from here. We know the derivative of arcsine. This is arcsine, it's just different notation. And then we know the derivative of arctan. And then again, I have to think about the derivative of 4 minus z, which will be negative 1. So I could change the numerator to be negative 1, or I could change this, instead of being a subtraction, make this, or an addition, make it a subtraction. Okay, and now we're all done. So it's long. You wouldn't want to try to simplify it or anything like that. Just leave it like that. All right, let's see the next part. G of w equals arctan of this value. So let me remind you that the derivative, again, of arctan, or tan inverse of just x, is going to be 1 over 1 plus x squared. So in this case, if I think about g prime of w, I'm going to take this inner function and I'm going to put it wherever there is an x value. Okay, so this will be 1 over 1 plus w over 1 plus w squared, all of that is being squared, times the derivative of what's inside. So I need to take this now, and I need to take the derivative, and I need to put it there. So I have to use the quotient rule. Quotient rule says take the denominator, 1 plus w squared. My handwriting leaves something to be desired today. Sorry, 1 plus w squared times the derivative of the numerator, 1, minus the numerator times the derivative of the denominator, all over the denominator squared. So again, that's really messy. You could try to simplify it. I could see you doing a few things, but you're not really going to be able to simplify it to the point where it's really, really nice. Okay, so I would just leave it like this and have this be your final answer.